Good evening, Los Angeles. This is David De Los Reyes. My topic tonight is pulsating direct current. What's pulsating direct current? Pulsating direct current is the current coming out from a power supply, okay, to power up our gadgets. This is a power supply, okay. The voltage of this is 12 volts, okay, and our load is a DC motor in which the input voltage is 12 volts, okay. The circuit inside the power supply is something like this. It's a pole wave rectifier. Pole wave rectifier meaning for the positive alternation there is an output, and for the negative alternation there is also an output. The figure is something like this. During the positive alternation, this is the output current. During the negative alternation, this is the output current. And as the process repeats itself, it keeps on giving a pulsating direct current. And actually, that's the output of this power supply. There is even a joke that have you seen a pulsating direct current or a current? What's the shape of a pulsating direct current? For you now guys who haven't seen a pulsating direct current using our oscilloscope, this is the view of a pulsating direct current. That's the nature of the current going to our gadgets. It's not so smooth, okay? It's pulsating. Okay? It's pulsating. Okay, let's try to bring out the operation of this and how come we bring out a pulsating direct current for our power supply for our gadgets. It's like this. For the positive alternation, when this graph will come out, okay, when this terminal is plus, okay, the flow of the current will be from this point here. It goes to diode number 1, okay, it goes to plus terminal. Plus terminal is the load. Our load here is the motor, okay, load. Then it will go to the negative terminal, it will go back here, it will pass here, then return on this side here. Meaning that when this is plus, this should be minus. The flow of the current is something like this, okay. And at that time, the output current is this. It is this. It is this one. For the negative alternation, when this graph of the voltage will come out, okay, meaning it's like this. When the negative alternation will come out, this will be plus, okay, and this will be minus. So the flow of the current is something like this. It goes here, it passes through diode 2, okay, it passes through diode 1, it go to the plus terminal of the load, negative terminal of the load, it will come back here, okay, it will not go back here, okay. It should be going up, okay, passes through diode 2 again, then goes back to the top terminal. Meaning, when the current comes from here, it will pass through diode 2, diode 1, through the load, it will go back here, it will go up to diode 2 again, then back to the top terminal. That's for the negative alternation. And the output current at that time, the output current will be this. It's the second one. as the polarity reverses again, when this is plus again, when this is plus again, it will repeat itself. It will repeat itself. Meaning the flow current will repeat itself. It will pass through diode 1, through the load, back to this terminal here. And the output current at that time again will be the third one. Okay? For the negative alternation again, this will be again be plus. Okay? So the current will flow from here. It goes through diode 2. It goes through diode 1. Passes through the load. Go back here. It passes through diode 2. Then goes back to the top portion. Because when this is plus, it should come back here. When this is plus, it should come back here. It's just the reverse. So as you notice it, for both the positive alternation and negative alternation, the current passes through the load in only one direction. Why in only one direction? That's why it is called direct current. Because in alternating current, one time the current passes through downward, and the other time it passes upward. That's alternating current. But for a direct current, it passes only through the load in only one direction. So if it's coming from here, it always comes from here. It passes through the load, then come back to the return circuit. So for alternation number 1, it will pass through diode 1, through the load, then will come back to this terminal here. For alternation number 2, okay, it will go up, coming from here, it will go up to diode 2, it will go to diode 1, passes through the load again. So as you notice it, the direction is always the same. That's why it is called direct current. It does not reverse direction. Passes through the load, okay, go back here, go upward, then return to the top terminal. Okay? That's how this pulsating direct current flows in a given circuit. Okay, this is actually a full wave rectifier, full wave. This is a full wave rectifier, meaning full wave rectifier because for both the positive and negative alternation, there is an output. This is for the positive alternation. This is the output current. For the negative alternation, this is the output current. Again, as it repeats the process, this is again the alternation. Okay, then this is again the alternation. So as you notice it, the output current is pulsating. Okay, it's that one. It's the one seen on the oscilloscope. So that's actually the graph of a pulsating direct current. Okay, so for you guys, if somebody is asking you, have you seen a pulsating direct current? I have already seen a pulsating direct current by using the oscilloscope. Theoretically, from our books, this is how we teach the pulsating direct current. And to prove that pulsating current, the view is actually something like this, that's it. Right? It's the same, right? Pulsating direct current. For a pure direct current, it's not like that. It should be something like this. But to attain this, the power supply should be a battery. It's not a rectifier circuit. Because for a rectifier circuit, whether we like it or not, for a rectifier circuit, we could not attain a pure direct current, the straight line. For a rectifier circuit, the current should be something, it got some curvatures. Okay? That's why it is called pulsating direct current. And that's it. Okay, the next time around, I will try to filter out more the pulsations by placing a capacitor again on the power supply, and let's try to smoothen out this one. Why smoothen out? We need to smoothen out because if this pulsating current is to be used for digital circuits, if the pulsations are too big, there might be some problem with the digital circuit. That's why engineers now try to design switch mode power supply in which the pulsations is very smooth. Okay? Because if it's not very smooth, it's not usable for a digital circuits. There might be some problem. The digital circuit might not work correctly. Okay? That's it, guys. That's the graph of a pulsating direct current. And theoretically, as we are teaching, this is the graph of the pulsating current on the book. And to prove that the pulsating current is actually like this, that's it. By using our oscilloscope. Okay? Our oscilloscope got something like this. I will try to remove it. The terminal of the oscilloscope got the ground connection, and this is the probe. Okay, for the ground connection, we connect it to the ground. Okay? And for the probe, we put it on the plus terminal. Hold on. That's it. Okay? So as I place the ground connection and the probe connection, the graph will come out. So whatever graph the output terminal is giving out, that's it. So if it's alternating for an alternating circuit, it should be alternating. But the next time around, I will show you the graph of an alternating current. But for the meantime, this is a pulsating direct current. It's the output of the power supply that supply our gadgets. Okay, thank you guys. This is for now. Okay, so the next time around, I will give you some more electronic circuit in which for you guys to familiarize yourself for those who don't know nothing yet about it. Okay, good night, Los Angeles.